Now we're going to talk about the number e. And you may be thinking, wait, e is a letter, not a number. Let me explain. If you recall from the compound interest talk, we had something that kind of reduces to 1 plus 1 over n to the nth power. Now in our interest problem, we had a t variable here, and we had a rate number here. But in essence, the same thing is happening here. As n gets large in this denominator and n gets large here, the number tends to focus on being a fixed constant. In calculus, we would write the limit as n goes to infinity of this is equal to the number e. And this number is, and you're going to see it, 2.71828, and I don't remember much after that. I used to have it a little bit more memorized, but that's just being silly. Anyway, try this. If you go 1 plus 1 over n to the nth, and your n is, say, 10, you're going to have 1.1 to the 10th power. Even that gets to 2.72, I believe, with a lot of numbers after it. It really does start focusing very quickly on this number e, which is this. No, you don't have to memorize it, but I want you to be aware of it. Graphically, let me see if I can do it in this space here. If I want to graph the function y equals e to the x, I really only have 2 points that I need to be concerned with. I know that e to the 0 power is, you should all be shouting, 1. Anything to the 0 power is 1. So when x is 0, y is 1. Right there. When x is 1, e to the first is e, which is 2.718. So when this is 1, mark up 2.7. That's going to be about right here. And so with these 2 points and knowing that it's an exponential function, I can draw e to the x pretty accurately by doing this. That's e to the x. Here's where it really comes into play. Notice up here I was talking about this limit as n goes to infinity. Again, don't let this bother you. This is calculus. This is not for this class, but I want you to get the idea of I'm putting in n really, really big. And then I want to be able to put in n even bigger than that. That's what taking the limit means. And I get this number here. Well, if that's true, then I'm going to go back to my compound interest thing. Basically, when my number of compounding periods gets infinitely small, that means I'm checking the interest on this loan not just every second, not just every half second, but continuously. It's continuously growing. Now, it may grow a penny in an hour, but it's still continuously growing. So I have what's known as interest that is compounded not daily, not by the minute, not by the second, but